One big problem with the scenario or sensitivity analysis is that it ignored interrelationships across variables. So whenever I changed the unit price, I didn't adjust unit sales at all. So even if the price were dropping, my unit sales stayed constant. They didn't increase to coincide with the drop in price. To combat that issue that you have with sensitivity analysis, scenario analysis can be performed. And so essentially with scenario analysis, you choose the best case, and that best case can have multiple changes at one time. So multiple variables changing at once. So for instance, let's say we think the unit price, perhaps people will prefer our product over the competition, and we can go all the way up to $3.75 per unit. And maybe customers will be more receptive, and instead of selling 75 units a day, I can sell 84 units a day. So 84 units. And maybe I think instead of growing at only 2% from year 4 onward, I think growth will be a constant 3%. So I have to have good reasons for my choices. I'm obviously just making these up, but what we would have to do is have a knowledge of the market and the customer base in that location. We would also need to try to predict where we think the economy is headed and what the demand for this type of product would be. But once we've chosen that, you input all those expectations into your spreadsheet. So I'm adjusting everything. I changed my price to $3.75, and I looked to make certain it was changing in years 2 and 3. I'm going to change this to 84 daily units. That changed for the year, and the daily units for the following 2 years rose as well, because I'm still expecting growth of 20% and 25%. And then finally, I'm going to change this to a 3% constant growth rate, and I just checked to make sure that rose when I pressed enter, which it did. So this is my best case scenario. So down here I'm going to put my scenario is the best case one. The net present value in that case was this 567,000. I'm going to copy it and paste it as a value. And now I need to estimate the probability that that will occur. And maybe I think that's 20%. Again, with some knowledge of the market for your product, you should be able to come up with an estimate for that. Then my base case was just the original value, and I am just going to pop over here and copy it because I know it was 403,000. Let's say there's a 60%, or let's go 65% chance of that. And let's say the worst case, so I'd have to choose my worst case scenario. I'll set the unit price to, I don't know, let's go $2.75 a unit. Sales of 65 units a day. And constant growth rate of just 1%. You can change more than 3 variables at the same time. I'm just choosing to change 2 or 3 of them. So I'll set this to 275, set the daily sales to 65 units, and my constant growth rate to 1%. So I will take this net present value and paste it here. Since this is 20% and that is 65%, and those probabilities have to sum to 100%, I know the probability of the worst case scenario is 15%. And I'm just formatting those so they look good. Now I can do a weighted average net present value. By multiplying the probability times the expected NPV of that scenario, and then sum all of them here. So there is the overall expected net present value. And I can do a standard deviation as well. So I can just use the built-in standard deviation. Actually, no, I can't. I can't use the built-in standard deviation function because these probabilities have different weights. So I'm going to have to do the more complicated weighted standard deviation. So what I'm going to have to do is I've got my mean net present value. What I need to do to calculate the standard deviation is find the square root of the weight of an outcome times the, and I called it probability here, but that's what it is, the weight, times the net present value of the outcome. Boy, I'm screwing this up completely. That's not what I need to do. Sorry. I'll take the weight, which I will call probability now, times the net present value for the outcome minus the weighted average net present value. And I want to square that. So take the net present value of your outcome, subtract the weighted average or the mean net present value, square that, then multiply by the probability. And I want to sum all of those, so I'm going to put a little sum in front of there. I know this is messy, but essentially that's what I want to do. So over here, I'm going to calculate this part. I'm going to take the net present value of the outcome and subtract the weighted average net present value and square it. So this is the net present value of outcome minus weighted average net present value squared. So the net present value of the best case scenario is 567,000. Subtract the mean of 402,000. Since I want to subtract the mean on every one of them, I'm making the mean an absolute reference. And then I want to square that. And I should be able to just copy that down. I'm going to take a quick look to make sure it took the worst cases NPV, subtracted the mean, and squared it. Now I will weight these values. So I will just say weighted column M. So I will take the value in column M and multiply by the probability or weight. And I can just copy that down. Then I want to sum them. So I've got here is my, it'll be easier if I do it this way. That's what column N contains, the weight or probability times the NPV for the outcome minus the mean NPV squared. And now I need to sum all of those and square root them all. So I am going to square root the sum of the values in my column N. So this is the standard deviation of the project. I'm going to actually just link it there and format it as a dollar amount. So with this information, I can now calculate the likelihood of generating a positive net present value, just like we did a couple of weekends ago when we had the Z tables and we looked up the likelihood of generating a positive return if we knew the mean and standard deviation of large cap stocks, for instance. Here I know the mean and standard deviation of this project's net present value, so I can figure out the likelihood of generating a positive NPV. So essentially, I won't work it all, um, but to calculate your Z score, what I would do is take the desired amount, subtract the mean amount, or NPV, and divide that by the standard deviation of the project. So my Z-score would be the desired amount. So if I want to know the likelihood of generating a positive net present value, the desired amount is 0 minus the mean of 402,000 divided by the standard deviation of 114,000. So I only need 2 decimals. The desired amount of 0 is 3.5 standard deviations to the right of the mean. So what I could do is figure out the likelihood of achieving a z-score of 3.5. Since that's 3.5 standard deviations away, it's going to be an incredibly high likelihood of earning more than 0 and a very low likelihood of earning less than 0.